Now for the next section, we're going to go ahead and take a look at absolute value inequalities, solving and graphing them. Now when we take a look at absolute value inequalities, we're going to take a look at two things. We're either going to have a conjunction or a disjunction, and what we're really looking at is the symbols. Now an less than symbol or less than equal to symbol, that's going to be the conjunction and. Now if we have a disjunction, we'll be looking for a symbol of greater than or greater than equal to. Either one of those two symbols will be a disjunction. Here's what it would look like in general. Now for the conjunction, you're going to have the absolute value of blop, and blop is just going to be anything that's inside the absolute value symbols. So the absolute value of blop is either going to be less than a positive number, or we could have another situation where we've got the absolute value of blop is less than or equal to another positive number. So you'll see one of those two situations, and then setting up for the problem, you're going to take a look at the first one. Either you'll have negative numbers less than the blop is less than the positive number, or you might use the less than equal to symbol instead, where you have the negative number is less than equal to blop is less than equal to the number. So more on the blops and the numbers in a little bit. Now similarly, when we have a disjunction, we'll be looking for the greater than symbol or the greater than equal to symbol, and our setup is just going to be pretty straightforward as well. We'll have the absolute value of the blop isolated on the left hand side is greater than a positive value, a positive integer. Or we could see the same thing but with a greater than equal to symbol. So one of those two things is what you'll see in the initial problem. Now the setup for these is going to be an OR problem. So first we're going to take away the absolute value bars. We'll have the blop is less than now the negative number. That'll be one inequality to solve. And then we're going to solve the other inequality by taking the blop and setting it greater than the positive number. So we're going to take that setup, and the word OR is going to go in between. The other way we could do it would be the similar way, but using the less than equal to and greater than equal to symbols. More on this as we take a look at our first example. So what we're going to do is take a look at example 8 here, where we have to solve and graph each of the following. Now in example 8, we've got the absolute value of 2x minus 3, so that's our blop, 2x minus 3, is less than 3. So 3 is our number, 2x minus 3 is our blop. Now to set this up, we've got to first recognize which symbol we have. We've got a less than symbol. A less than tells me that this is going to be a conjunction problem. To set this problem up, we're going to set it up as negative 3 is less than 2x minus 3 is less than positive 3. So that's going to be our setup for this. Once we're done setting it up, then all we have to do is solve the inequality. Now, once we have this set up correctly, what we're going to do is start by adding 3 to each piece. On the outside, if we add 3 to negative 3, we'll get 0 is less than. If we add 3 to the middle, we're only left with 2x. If we add 3 to 3, we end up with 6. Next, we're going to divide each piece by 2. Dividing each piece by 2 yields the following. We'll have 0 on the outside, x in the middle, and 3 on the right side. Our final compound inequality is going to be 0 is less than x is less than 3. Graphing this, we'll have to make sure we pay attention to the two numbers that are on the outside, as well as which type of circle or dot we would use and which way we would shade. This is what it would look like. We would have open dots at 0 and 3. Since x is in between, we would shade in between the values of 0 and 3. And that's what our picture would look like. Now, again, some technical pieces. Make sure that you have arrows on the end of your number line. Make sure the numbers 0 and 3 have open dots, and that we've shaded in between the numbers 0 and 3. That's all there is to this type of problem. For question number 9, we've got the absolute value of 3x plus 5 is greater than or equal to 10. So right off the bat, you want to take a look at the symbol greater than and equal to. We've got the absolute value on the left-hand side greater than or equal to a positive number on the right-hand side. So this is going to be an OR problem or a disjunction. So here's how we'll set it up. 3x plus 5 is greater than or equal to 10, or 3x plus 5 is less than or equal to negative 10. So we'll take our blop, which is the absolute value of 3x plus 5, and we'll just set that, and you can see that because it's highlighted in green, and we'll have 3x plus 5 is greater than or equal to positive 10, or 3x plus 5 is less than or equal to negative 10. Now, solving each one of these is just simple arithmetic. On the left-hand side, we'll first start by subtracting 5 on each side. Then, we'll divide each side by 3 to get x is greater than or equal to 5 over 3. Now, on the right-hand side, first, again, we'll start by subtracting 5 on both sides. So when we do that, we'll get 3x is less than or equal to negative 15. Dividing both sides by positive 3 gives us x is less than or equal to negative 5. Now again, when we go to graph this, we'll have to pay attention to the inequality symbol as well as what direction we want to shade. Now because of the inequality symbol, I'm going to put a solid dot on both 5/3 and negative 5. Now 5/3 is really close to 2 because if it were 6/3, then x would be 2. But since it's 5/3, it's just going to be a little less than that. So let's go ahead and put our dots on the graph. Now, with x being greater than or equal to 5/3, I'll have a solid dot and I'll shade to the right hand side. Since x is less than or equal to negative 5, for that piece, we'll go ahead and shade to the left of negative 5. So our resulting graph would look like what we have here. Be sure that you shade correctly in each direction, and also be sure that your dot is correctly filled in. Now, if you understood examples 8 and 9 and how we work those out together, examples 10, 11, 12, and 13 are all just going to be very, very similar. So if you think you've got this down, go ahead and try those problems now and see how you do. Pause the video and then go back and compare and see if you ended up with the same answer and the same picture. So see if you did solve it correctly and graph it correctly for numbers 10 through 13. If you want to do it together, let's keep going. Alright, so here for example 10, we've got the absolute value of 3x plus 4 is less than or equal to 8. So the blop is 3x plus 4, which means that's going to go in the middle. Negative 8 will go on the left-hand side, and positive 8 will go on the right-hand side. Now for our third line, we'll subtract 4 to the left, the middle, and the right. And that'll give us negative 12 is less than or equal to 3x is less than or equal to 4. Now when we divide each term by 3, we'll end up with a result of negative 4 less than or equal to x is less than or equal to 4/3. So that is the solution for this inequality. Now, let's go ahead and graph. Now at negative 4 and 4/3, you're going to have a solid dot. Now 4/3 is slightly more than 1. It'd be 1.3 repeating. Now since x is in between those, we're going to shade in between negative 4 and positive 4/3. So we have solved and graphed that problem. Not too bad. I'm sure you guys did fine with this one. Go ahead and hit pause if you think you can do 11 on your own and come back and see how you did. If you want to do it together, alright, here we go. Now for number 11, we've got the absolute value of 6 minus 2x is greater than 14. So you've got to recognize that this is a greater problem, and in a greater problem, that's a disjunction. So we're going to set this up and break it apart into two pieces. The first piece is going to take our blop, 6 minus 2x, and set it greater than 14. Our second piece is going to take our blop, 6 minus 2x, and set that less than negative 14. Now it doesn't matter which side we start to solve first, so we're going to go ahead and take a look at 6 minus 2x is less than negative 14. If you subtract 6 on both sides, you'll end up with negative 2x is less than negative 20. Now, be really careful here when you divide both sides by negative 2, because you've got to remember to flip the inequality symbol. So that's going to give us x is greater than 10. So that's the first piece that we've got to do. Now for the piece on the left-hand side, 6 minus 2x is greater than 14. Again, we're going to use the same technique, same process. We're going to start by subtracting 6 on both sides, and that'll give us negative 2x is greater than 8. But again, be careful. Make sure when you divide by the negative, you don't forget to flip the inequality symbol. That'll give us x is less than negative 4. So hopefully you've got your inequality symbol on both of those pieces correct. Because if your inequality symbols are wrong, then your graph is going to be totally wrong too. So our graph is going to be based on what we've got for our inequalities. For the left-hand piece, x is less than negative 4. We're going to put an open dot at negative 4 on a number line and shade to the left. For the other piece, x is greater than 10. We're going to put an open dot on positive 10 and shade to the right-hand side. Hopefully your picture and my picture they look the same thing. If not, pause the video, rewind it, and go back and fix what you did. Let's go ahead and take a look at examples 12 and 13. But I think by now you guys are really getting the hang of this. For number 12, we've got 9 minus the absolute value of 3 minus m is less than or equal to 1. Now my blop here, the piece that's the absolute value, is 3 minus n. That's not alone on the left-hand side, so we've got to make sure that we take the 9, and we're going to have to move that over to the other side. Now in doing so, we'll end up with the following, but you're going to have to be really, really careful and watch your signs here. Now when you move to the second line, you're going to just subtract 9 on both sides, and I'm sure everybody did okay with that, but just be really careful that you don't forget the negative sign out in front of the absolute value of 3 minus m. Now what we're going to have to do to get rid of that negative sign is we're just going to multiply both sides by -1. Now in doing that, don't forget, flip the inequality symbol. So now after doing that, we've got the absolute value piece, our blop, in this case the absolute value of 3 minus m, that's all by itself on the left hand side, and that's greater than or equal to +8. What we've got to recognize here is that we've got a greater problem, or a disjunction, or we're going to use the word or. So this is just going to be like problem number 9 and problem number 11 that we just did previously. So if you understood those two problems, this one will be a piece of cake for you as well. Now let's make sure that we get our setup right here. On the left hand side, we'll have 3 minus m is greater than or equal to 8. Or, on the right hand side, we'll have 3 minus m is less than or equal to -8. So on the left hand side, don't forget to switch the direction of the inequality symbol, as well as change +8 to -8. Now when I solve the left hand side, again, be really careful as you subtract 3 from both sides. You'll end up with -m is greater than or equal to 5. But then here's where a lot of people could make the mistake right here, so don't be that person. When you divide both sides by -1 or multiply both sides by -1, do not forget to flip the direction of the inequality symbol. So you'll end up with m is less than or equal to -5. So that's one of our solutions to our inequality. Now when we work on the right hand side, we're going to have to deal with the same issue. Make sure, subtract 3 on both sides, that'll give us -m is less than or equal to -11. But then when we multiply or divide by -1, we're going to have to make sure, don't forget, change the direction of the inequality symbol. And make sure you change the sign of the number that's on the opposite side. So -11 is going to go to +11. Now that we've got that, we can go ahead and take a look at graphing this. Now, so on the left hand side, we should have a solid dot at -5, and it should be shaded to the left. On the right hand side, when we have m is greater than or equal to 11, we're going to have a solid dot at 11, and we're going to be shaded to the right hand side of our number line. So hopefully you guys got this down. You're just cruising right through these, and now these are no problem. So that's how you graph number 12. For question number 13, we've got a pretty funky looking absolute value inequality. So here we go. We've got 11 plus 1/2, the absolute value of 4x minus 1. All of that is greater than 13. Now the first thing that we're going to have to do is we're going to have to get rid of the 11. So the 11 is going to be the first thing to go. To get rid of that, we're going to use the subtraction property, and we're going to move 11 to the other side. When we do that, we'll be left with 1/2 times the absolute value of 4x minus 1 is greater than 2. But the blop, the 4x minus 1, it's not alone yet, so we still have to get rid of that 1/2. So now we're going to multiply both sides by 2. If you did that correctly, we've got the absolute value of 4x minus 1 is greater than 4. Finally, we've got the absolute value piece, that blop, is going to be all by itself on the left hand side. Now right up to this point you guys should be okay. So now the next thing we're going to do is go ahead and set up our inequality. So what I want you to do is go ahead and set yours up, go ahead and solve it. You'll solve the two sides, and I want you to double check and make sure that you solved each one correctly, and check your answer with my answer. So go ahead and hit pause now, work out the problem, and then come back and check your work. How did you do? Hopefully on the left hand side you have x is greater than 5/4, and on the right hand side you have x is less than -3/4. As long as you did your arithmetic correct, you should be well on your way to now graphing this problem. So if you got this right, let's continue on and go ahead and graph the problem. If you got it wrong, go back, double check your work, make sure you pay attention to the direction the inequality symbols are and that you did your arithmetic correctly. So now, go ahead and pause the video if you've got this, graph it on your own, and come back and check, see how you did. But if you want to go on, here we go. We've got one more thing to graph. Let's get it done. Do we have the same thing? Hopefully we do. We should, because I'm pretty sure that you guys have got this down solid now. We'll have an open dot at -3/4, and we'll be shading that one to the left-hand side. We'll have an open dot at 5/4, and that will be shaded to the right-hand side. Now you've only got one more problem to do, the thinker problem. So let's take a look at that one. We've got -2 times the absolute value of x over 4 minus 9 is less than or equal to 12. Now a lot of people are going to focus on the x minus 4, but you don't even want to look there yet. First thing you want to do is look at the -2. We want to get rid of the -2, so that means we're going to divide both sides by -2, and don't forget, flip the inequality symbol. Now hopefully what you got and I got actually match. Now we've got the absolute value of x over 4 minus 9 is greater than or equal to -6, but here's the part where you're going to have to do a little bit of thinking. Take a look at the part on the left, the absolute value piece. The absolute value of anything will always be positive. So the part on the left will always be positive. Now if I look over onto the right hand side, I've got -6. So wait a second here. -6, well that's a negative number. That's always going to be a negative number. That's never going to change its value. So on the left hand side we've got something positive. And on the right hand side we've got something negative. Something positive will always be greater than or equal to something negative. So what does that mean as far as our solution is? Well, if you have a situation like this, the correct answer for this type of problem is going to be all real numbers. Because no matter what number you pick, it will always work. So all real numbers will work in this situation. Now that could be denoted 3 different ways depending on textbooks and the way your teacher might ask you to figure this out. So you could actually write out the phrase all real numbers. You could put a fancy letter R that has that little extra piece in it, kind of like paragraph does in English class. Or you could use interval notation and write from -infinity, comma, to +infinity. And notice both those have soft brackets on it, and more on that later on. This problem, if you figured that out and you were able to hang with that one, that's pretty good. This is a thinker problem. Alright, hopefully by now you've got down solving absolute value equations as well as solving absolute value inequalities.